All right, so we talked about parallel planes. Another definition that we have seen before is skew lines. Skew lines are non-coplanar lines that never intersect. We have looked at skew lines before. We do, but we'll just look at it again so we remember what skew lines are. In this example, line K and line L are skew. What are some other skew lines in that example? What's another pair of skew lines? Line Q and P. They're non-coplanar and they will never intersect.
K and L. Oh wait. I see.
K and L we've already said, okay. Anything else?
L and Q.
L and Q. So just to review what a skew line is, it's been a little while since we've talked about it. William. Now the next definition is one that we have not seen before, and that is the definition of a transversal. A transversal. And a transversal is a line that intersects two or more coplanar lines at different points. A transversal is a line that intersects two or more coplanar lines at different points. And we will be seeing transversals through the rest of the year. Parallel lines cut by a transversal are often types of questions that you might even see on the SAT or later tests, standardized tests, because it's something that occurs so often. But in the examples that I have, T is the transversal on the first drawing, and U is the transversal on the second drawing. So T and line U, line T and line U are our transversals because they intersect two or more lines, in this case just two, at different points. And we specify at different points because you could have two lines that really name them differently, but it'd be the same line. It would just intersect at one point. So two or more lines at different points. So T is a transversal for line M and N, and U is the transversal for lines R and S. All right, we will see transversals a lot. Let's go to the next. When a transversal intersects two lines, 8 angles are formed. When a transversal intersects two lines, notice that 8 angles are formed. What line is the transversal in this particular diagram? Line K, that's a T. Line T, it does kind of look like a K from there, doesn't it? Line T is our transversal. It does resemble a K, but line T is our transversal. And we have 8 angles formed. Each of these angles have types that we call them. In this particular case, the way I have these angles numbered, angles 1, angle 2, angle 7, and angle 8 are called exterior angles. exterior angles. Notice they are outside of the line. They're exterior angles. They're outside of A and B. Angles 3, angle 4, angle 5, and angle 6 are interior angles. And we're going to break that down a little bit further. But first we wanted to be sure and see the difference between exterior angles and interior angles. Interior angles lie inside, in this case, lines A and B. Okay, so we have exterior angles for exterior, for interior. And we can narrow them down even a little bit more. Alternate interior angles and if you have to abbreviate this, you can use this as an abbreviation. Alternate interior angles are a pair of interior angles that lie on alternate sides of the transversal. These are a pair of interior angles that lie on alternate sides of the transversal. Oops. So in our example, in our diagram, one pair of alternate interior angles would be angle 3 and angle 6. Do you see any other alternate interior angles, Darby? Angle 4 and angle 5. These are also alternate interior angles. So they're pretty easy to identify. They lie in between the two lines, and they are on alternate sides of the transversal. If we go to the next, again, I have a diagram, looks similar to the last one. This time we want to define same side interior angles. And these are a pair of interior angles that lie on the same side of the transversal. So these are pretty self-explanatory definitions or terms. Same side interior angles are a pair of interior angles that lie on the same side of the transversal. So in this example, we have angle 3 and angle 5. These are same side interior angles, and that's how you can abbreviate that. Same side interior angles. Armando, do we have any other same side interior angles? Angle 4 and angle 6. These are also same side interior angles. All right. Next definition is corresponding angles. corresponding angles, or a pair of angles which lie in the same position relative to the lines that form them. Corresponding angles or a pair of angles that lie in the same position. Relative to the lines that form them. Now, I'm not going to pull it back down, but you can look at the diagram on your paper, and if we were to name a pair of corresponding angles, we could say that angle 1 and angle 5 are corresponding angles. And you can abbreviate it like that. Corresponding angles. Angle 1 and angle 5. Will? What's another pair of corresponding angles, Will? Angle 2 and angle 6. Any others, Kason?
4 and 8.
Angles 4 and 8. And what else, Anna?
3 and 7.
3 and 7. So they are in the same position relative to the lines that form them. One thing I forgot to say about same-side interior angles, you might also see them sometimes referred to as consecutive angles. Forgot to mention that. Same-side interior, some books or some papers might say consecutive angles, but that's the same as the same-side interior. Yes, sir?
Can corresponding angles both be exterior angles, or does one have to be interior?
Well, if they are in the same position relative to the line that formed them, that's a good question. Notice in my example, it's got to be above the line, so this has to be above the line. They can't be the same. They can't both be exterior. One would be interior and one exterior. Okay. Armando.
Are you recording this?
Yes. Do you have a question?
No, I just want to ask.
Okay. All right, any questions so far? Pretty easy. All right, let's look at the next sheet. Okay. I want to name the alternate interior angles. Shelby, what alternate interior angles do you see?
Angle 3 and angle 6.
Angle 3 and angle 6. Any more? Will?
Angle 4 and angle 5.
Angle 4 and angle 5. All right, let's look at same-side interior angles or consecutive angles. Casey, do you see a pair of consecutive angles or same-side interior?
Angle 3 and angle 5.
Angle 3 and angle 5. Hannah?
Angle 4 and
Angle 4 and angle
angle 6.
6. Good. And then corresponding angles. Do we see corresponding angles? Leah, what's a pair of corresponding angles?
Angle 2 and angle 8.
Angle 2 and angle 8 are corresponding? Are they?
Or 2. Wait. Oh, angle 2 and angle 6.
Angle 2 and angle 6. Good. They can't both be exterior, so the question that Lucas asked was a good question. Cameron?
Angle 1 and
Angle 1 and angle
angle 5.
5. Gilberto?
Angle 4 and angle 8.
Angle 4 and angle 8. Notice we always want to name them as angles because they're not just numbers. Monica?
Angle 3 and angle 7.
Angle 3 and angle 7. Do you see any other kinds of angles here that we haven't talked about today? Zach?
Like angle 1 is an obtuse angle.
Okay, it is an obtuse angle. It looks like it's an obtuse angle. Any other kind of pairs of angles? Brandon?
Supplementary, complementary.
We,
Or supplementary.
we do see some supplementary angles, and if we were going to say they were supplementary, what would we need to say first?
They're a linear pair.
They're a linear pair. So we see linear pairs, which by the linear pair postulate tells us they're supplementary. So we have linear pairs. Any other kinds of pairs of angles?
The adjacent angles.
We do have adjacent angles, but we also have vertical angles. So we can't forget that we have linear pairs and vertical angles as well as the different types of angles that we've talked about. All right, let's look at what I'd like for you to do is just take a couple of minutes and name all those different types of angles. All right, so we got all of these different types of angles named. Let's look at the last sheet, which is again a review. We talked about Euclid's parallel postulate. We said that this is the thing that makes Euclidean geometry different than other types of geometry. And this is will be in your note card section. If you don't have this already down, you want to be sure you've got Euclid's parallel postulate. But given a line L and a point P that's not on the line, here we have line L in red, point P is on the green line, there exists one and only one line through P that's parallel to L. There are no other lines through the point P that could be parallel to L, and that is Euclid's parallel postulate. Remember, the parallel postulate for Riemannian and hyperbolic geometry were a little bit different than they are for Euclidean geometry, which is a flat space geometry. All right, one thing that I don't have on this note, it's in your book on the page right in front of your assignment. It is the corresponding angles postulate. And this is not worded exactly, but basically, given that two lines are parallel, or given two parallel lines cut by a transversal, you have it more formally in your note card section on RenWeb. Given two parallel lines cut by a transversal, corresponding angles are congruent. Okay. Given two parallel lines cut by a transversal, corresponding angles are congruent. This is only true if your lines are, if you're told the lines are parallel. If you know that the lines are parallel, then corresponding angles are congruent angles. So you'll use that in your homework assignment, which is on page 223 to 225. 1 to 15. And then 17 to 26 and 28. Be sure that you draw all diagrams. I think some of the questions say name the same side interior angles. So write either same side interior angles and then list out your angles that are same side interior or that are alternate interior. Be sure that I could tell what the question was by the way that you have answered your question on the paper, right? Don't just write down the angles. Write down what kind of angles they are. Be sure you draw your diagrams. Brandon.
So on number 11 and 12, can we just draw the lines, or do we have to like draw the car too?
No, just the lines and the transversal. You don't have to, you can, the windshield wipers, you don't have to draw the car. Unless you just are very artistic and you like to do that kind of thing. All right, Will, did you have a question? Let's start out by yourselves right now. Let's do this alone. Okay?